Okay, so right now we're going to talk about Unit 2, Worksheet 5, multiple representations of motion. We're going to look at problem number 7. And from this problem, we're going to find out the time and position that object A and object B intersect at on our position time graph and our motion map, as well as one other representation of motion. For this problem, we are given the written description. Object A starts 10 meters to the right of the 0 position and moves to the left at 2 meters each second. Object B starts at the 0 position and moves to the right at 3 meters each second. So the very first thing that I'm going to do is I'm going to set up my motion map. Because of the way that the written description is written, it'll make it really easy for me to set up a motion map. Object A starts 10 meters to the right of the 0 position, so I'm going to look at that motion map and add up to my 10 meter position. I'm going to go by increment of 2 meters for that motion map. So the first tick is 2 meters, second tick 4 meters, so on and so forth, up to 10 meters. And then I'm just going to continue along with this, seeing as I have the space. So 12 meters and 14 meters. Once I have that, I can start off with my motion map. Object A is going to start at 10 meters. So I'm going to put down that that is the starting position. That is going to be a time of 0 seconds. Each second it moves to the left at 2 meters each second. So at a time of 1 second, the position is 8 meters. 2 seconds, 6 meters. 3 seconds, 4 meters. 4 seconds, 2 meters. And then finally at 5 seconds, it will be at a position of 0 meters. I've drawn that there, so I'm just going to add my velocity vectors. Spacing wise, I'm using half the distance between each of these points. And then 5 seconds is the last one that will be represented on that position time graph, so I'm just crossing it off to indicate that's where it ends. Last thing I'm going to do is to label that these are all V's for velocity. And then these are all the same size velocity vectors because it's a constant velocity, so I'm adding my congruency marks. Object B does not start at 10 meters, it starts at the 0 position, which is a position of 0 meters. That's where it is going to start. At 0 seconds, that's where it is. It moves to the right at 3 meters each second. So at 1 second, it is at a position of 3 meters. 2 seconds, a position of 6 meters. 3 seconds, a position of 9 meters. 4 seconds, a position of 12 meters. And then at 5 seconds, it would be at some position of 15 meters. So I'm just going to put that approximately where that would go. 5 seconds will be the last thing represented on our position time graph. So I'm just going to put an X over that point on our motion map. And then I'm going to add my velocity vectors. Once again, using the spacing between each of these points as a guide for how long those velocity vectors should be. Label them V for velocity. And then I'm going to use congruency marks to say they're all the same size. I'm going with 2 slashes here instead of just 1 to indicate that they are a different size than the velocity vectors for object A. So that's going to be our motion map. If we want to know the time and position that they intersect at or pass each other at, I just need to look at the motion map. They'll be at the same point at the same time at 2 seconds, which is represented right here. Now that I have this representation of motion using a motion map, I can set it up on a position time graph. Right now, we don't have any scale on the y-axis, which represents our horizontal position, so I'm going to set one up. Right here, it's going to be about 5 meters, right here, about 10 meters, and at the very top, 15 meters. I'm just setting it up that way because the maximum position we have on our motion map is 15 meters for object B at 5 seconds. Then, once I have this set up, I am going to use my straight lines, and I'm going to change the color just to make it a little bit easier to see and color coordinate. Okay, or not. So, object A starts at a position of 10 meters, and 5 seconds later, it is at that position of 0 seconds. So I'm going to label this with a letter A to indicate that that is going to be my position there. Object B starts off at 0 meters, and then at 5 seconds, it's at a position of 15 meters. Okay. So that will be object B. Looking at our position time graph, we can definitely see that they cross paths at 2 seconds. And unless we have a more precise scale on our x-axis, the y-axis, which represents our position designated by the letter x, we don't necessarily know what position that would be. But with a more precise scale, we could end up trying to determine what that position would be. Now, the last thing that we're going to have is for our velocity time graph. Remember, at the time axis, that is a velocity of 0 meters each second. So I'm going to have first object A, which travels left, which indicates a negative velocity, -2 meters each second. So this line right here can represent object A. Object B moves to the right, so positive 3 meters per second. Sorry about the bad B there, but that is going to be B at our +3 representation. We can't necessarily use a velocity time graph to figure out our time and position of intersection. We could use it to figure out displacement, but that won't be overly helpful right now. But these are our 3 ways to represent motion using our, well, 3 ways that we can represent motion here.